Good morning. How's everybody doing this morning? If you've been keeping track, you know that today we're going to do some wiring in here for you. We've got Jeremiah Swann is going to be coming here and do some wiring on a 9S meter socket for us. He's got a can here. He's going to do some wiring, show you guys how to wire up a socket. Before we get started, I just wanted to say these words, be of good cheer. And the reason why I'm saying that is, I know the reason why this has been popping in my pea head here in the last couple of days is, you know, when you're reading about the situation, there's one expression for that in Greek, be of good cheer. And it's used 5 times in the Bible. And it's always in really bad situations. Paul is about to get literally torn apart by Sadducees and Pharisees. And then got them here, you've got it in Matthew with the bedridden paralytic. And Jesus says, be of good cheer, your sins are forgiven. Then a woman, 12 years bleeding in Matthew, and he says, be of good cheer, daughter, your faith has made you well. Then on the Sea of Galilee, when they're about to sink, and Jesus says, be of good cheer, as I do not be afraid. And then when Jesus tells them he's going to be crucified, another horrible, they're probably freaking out. You know they would be. And he says, in the world you have tribulation, but be of good cheer, I have overcome the world. And then, like I said, in Acts, he says it again. As Christians, in the midst of all this, and I find myself doing the same thing, getting pulled down between the news and people are complaining. We're in tough times right now. But here's where we can be a difference as Christians, and we can be of good cheer because we know who's in control. So I'm going to pray real quick. Father, thank you so much for the chance to be of good cheer in the midst of chaos and darkness and morale being in the toilet right now, and people are just looking down instead of up. Well, Father, we want to look up. We want to look up to who's in control. You're in control, Father. You're in control of everything. So we should be of good cheer because of that. And we know that no matter what happens now, the end game is what we're worried about as Christians. We're worried about trying to see as many people as we can join us in heaven. So let us be of good cheer and let us be a light in the midst of this, Father. So maybe someone will ask us, how come you're in such a good mood when things are so bad? And that will give us a chance to talk about Jesus. And it's now in His name I say and ask all these things, the one who paid it all, my brother, Jesus Christ. Amen. All right. So, as you know, today it's going to be Jeremiah and I in here. Chris Mullins is on vacation. Can y'all believe it? Mullins actually took vacation. So good for him. So he's staying home with the family. He's had a stay vacation or a staycation. So we've got the COVID. We're doing the series again. This is Series 10. I can't believe that. But it is Series 10. So today we're going to wire a 9S meter socket. Then we're bringing Swann in again on Thursday to do a 2S meter socket. Okay, we keep telling y'all, if you've got an idea, send it in to us. We've got one in here that we're trying to incorporate into another session here. But you can see, next Tuesday and Thursday are open right now. We've got some ideas we're spinning around. But if you've got a good one, please send it in to us because we definitely take them. We've got one now out of Jesse down in Florida way, and we're going to try and work it into maybe an advanced. And do me a favor, send in on the chat room or send in if you look at this a little bit later because we got till the next week. We were thinking about doing one on advanced testing, and it may be some things that the Powermetrix units can do that you don't normally use out in the field, but once you see that you can use it, then you might use it. So we're going to do advanced capabilities. We're going to talk about some of the ways you can use a test to determine the example we were given by Jesse is a great one to troubleshoot with. So we're just thinking of maybe doing one of these that will be more of an advanced meter tech, use of the machine, testing in the field, whatever you want to call it, give whatever title you want, but just some more of the advanced stuff, okay? But if you've got ideas, please send them in. So, what we're going to do is I'm going to ease over here to this 9S can, and we're going to let Jeremiah go over it. He's going to just walk through it. We'll both be commenting on it, and Jeremiah's going to wire this thing up. And as we're going through it, if you've got any questions, holler on the chat room. But we're just going to go over it right from the very beginning, and Jeremiah's going to talk about what all of these terminals are, so you can see the connections between the socket, the terminals on that socket, and down at our test switch, so you can see where we have to make our connections. He's just going to take it right from the very start, going into the bending the wire, making the terminations and everything, okay? So we're going to go over the can now.
All right, good morning. So we do have a 9S here. It's got a 13 terminal that we're going to wire up. So I wanted to start out first just talking about the test switches. So how can you tell the difference between a voltage and current, where they go? As you see right here, we got the black dividers. That'll be your voltage so that we can separate our voltages and nothing will come in there to short it out, cause an arc. Then this this one right here you see is solid, don't have a test switch in it. That's going to be for our neutral. You don't never want to break the neutral, so you want to make sure it's there, solid, one run continuous. Then you see the ones like this that we can open all the way, that you can actually take with our test switches and insert the duck bills. So that'll be our return, so it'll also flow. Then you got the ones like this that you can't open all the way. So that's going to be your potentials. So when you come down from the top side of the meter, you'll come down to here for your potential. So you see it all the way through. You'll have A, B, C returns, A, B, C potentials. Then you can come off the bottom side, that'll go to your CTs and your neutral. The bottom side of here will go to the A, B, C voltage. So now that we've looked at the test switch, before we start wiring, we'll look at the top side of the meter base. So right here, we'll start at the bottom. Returns. So as we said before, your return, they'll come all the way open. A to A. Then we'll go over here to this side. If you can see it where my finger is, this is where your voltages are going to go. A, B, C voltage. Here's your little stabs. Now it's different on a 9S than say a 16S or a 2S meter. Most of your stabs are the big ones. Here it's your currents are your big ones instead of the voltage. So up here at the top you'll have your A, B, C currents. Then on this side you'll have a neutral return, which will come back down here, then we'll tie it to the can. So I wanted to go through that so people kind of have an idea. And not all meter bases are the same, not all 13 terminal switches are the same. You can actually have your voltages over here, or you can have a voltage, a return, a potential. So you actually got to look. That's why I wanted to point these out. That's where your voltages are. They're going to have these little plastic dividers beside of them so you don't short nothing out.
And everything's dead here. This is just a can sitting on top of a table. So before somebody says wear your gloves and everything, this is absolutely totally dead, not connected to anything.
Yeah, and also a lot of people have different colors. We're actually going to use red, yellow, blue, A, B, C, just like it would be out on the line side, on your primary side voltages. To wire a can, you're going to need strippers, cutters, crimpers, straight screwdriver, 3/8, and I think this is 7/16. So that is the tools that you will need to do that. So we're going to start out. I like to do my returns first to get them right here because they're straight down. Is the way that I was taught to do it. Some of these I already have that will be pre-made, and some of them I'll actually cut, bend, show you. Returns right here I have made up for time purposes. So we're going to start out right here. This would be your A phase. Now some people will use solid wire. Does anyone know what the benefit of having solid wire versus having a wire that you're going to have to crimp on? What do you think would be a benefit of having solid wire, John, versus stranded?
You kind of said one, you wouldn't have to crimp it.
You wouldn't have to crimp it. What? A crimp's just a what? Point of failure.
Yep.
Just another point of break. So when it heats up, you have loss. So as you see, take it down, tighten it. Another thing about stranded wire versus solid wire is uniform, bending it. Solid wire bends easier and will stay formed a lot easier.
And if you noticed when Jeremiah first started and he was going through the test switch, that's why when we talk about it, I mean, you don't think that, well, when do you actually use all that? I mean, you use it in the testing, but of course then you're going to use it on this wiring as well. So you can determine ahead of time, kind of get in your head what goes where. Now, if you've done it for years and years and years, it becomes more automatic, but you don't want to get too automatic there in the field. I mean, that's one of the big things that can cause people problems out in the field. You don't want to get too automatic. You still want to use your eyes and your head and look things over before you start actually reaching in stuff. So If you get a lay of the land of know what you got with your test switch, you know what you're about to have to do and where you're going to have to make your runs to.
And I've been to some sites to where you see all one color. What would be a problem if all of this was one color wire? Say we had all orange color. Well, for one, it just don't look good, and for another, it's just a nightmare if you have to come out and troubleshoot it. Because we all know, we've all been in the field. When does something break? Middle of the night, rain. It don't happen when it's nice and pretty outside.
Nope.
So you got to stand out there with a flashlight, and if you got all one color, you're trying to track it all down.
Sometimes.
Now, as you see, this is B, going to B here. We'll try to bend this to make it look nice and neat. You could all throw it all together, then bam, be out there in the middle of the night having to try to track it down. If you make it neat now while it's dead, when it's hot, you can see it a lot easier. And nowadays you can get meter bases that's pre-wired on the top.
Oh, yeah.
Which is convenient, but if you don't know what goes where, then it could be a problem trying to check it.
Yeah, you know, that kind of goes to what we talk about when we're talking about the test equipment, which is you want to know what you're doing. You don't want to just say, I hit the button. No, you want to know what's happening when you hit the button. You want to know what's going on. That's what pays you just untold dividends out in the field trying to troubleshoot something. If you don't know what's going on, you're just saying, well, what I always do is I hit that button, then I hit that button. And then when something doesn't go right, then what do you know? All I know is to hit that button and that button. So knowing the flow and what's going on here, not only does it help you to troubleshoot, it's also safe, a little bit safer for everybody as well.
So I have got my returns wired. They're ready down to where they need to be. So I'm going to come over here now, and I'll start on this side right here. We'll start out with A voltage. As you see, it don't have a terminal up here at the end. It's just got a flat terminal that you'll just push your wire into. Tighten it down. Then go straight down to A test switch. You want to make sure that it's bent nice. You don't want to overbend them. You can't overbend them. Stranded wire will break the strands inside, which is going to cause problems over time. So A phase. I said before we was going to use red, yellow, blue. So we'll do B phase now.
Do you usually run solid?
Yes. Man, do you see where I dropped that? I like solid because of the point of, and see, I am human. I do make mistakes. I do drop things.
That's easy enough.
Well, you can do it. I didn't want to mess Jared Plum up.
Go ahead and grab it.
Where'd it go?
There. Now, you know, anybody that's been out there in the field with me know I like to just get it done.
Well, let's say that brings up a good point of dropping something.
Oh, yeah.
You're bringing it up on a pole. you're using wood screws to mount it. Anybody ever seen a wood screw drop in behind one and you can't find it? Short it out later, then what happens when you short one phase out? You lose how much of your revenue? That happens.
Oh, yeah.
That's why you like to test. So I will use blue wire
All right.
for our C phase. So we're just going to unroll it. Bad habit putting tools in my back pocket. So I take and tighten it down right there.
So the others were pre-made, but C-phase,
Yeah.
you're going to actually show them the whole,
So
the
I
whole deal.
pull it out right there to keep it uniform with the others, because you could actually take a little tie wrap, bring it down like that, bend it. Like I said before, don't over bend it. All you need is about a 90-degree bend. Make it look, because you don't want a jumbled mess out there in the middle of the night having to troubleshoot it.
Usually tie wrap them?
Yep. It just, they don't fall around, flop around. Strip it. You can get terminals that are insulated. These are not, which is not a big deal. So we'll take, I thought I had it in there. I just put it in there to hold it. Put my wire where you see it come out the end. Crimp it. You can see it's nice, tight.
Nice.
Let me see if I can drop this one. But like John said, stay of good cheer.
That's it. Be of good cheer. So now that completes.
So that right there would complete our voltage. So we're tight. We have red, A phase, B is yellow phase, blue is C phase. We have them run to their proper voltages on the top side there.
And do you do the neutrals next, or do you?
So I'll run the neutral over here to down here next. I have it pre-made a little bit. Cut it a little long, so we'll put it on right here. I'm wrong. What did I do? This should be a potential. My neutral's over here. Solid. I'm used to my 13 terminals.
You get wiring them the same way for 20 years.
Yep.
I was going to ask the question. Did you hear it, Destin? That little, you heard that switch closing? I heard it.
So it will go here.
Right before he went.
I've seen that switch. I get that out. This ain't right.
There's a switch on there. There you go. Because we go back to the good information you gave us on the front end, which is if there's no break in it and everything.
But don't want to be able to
that's
break
the
a neutral.
That's right.
So we'll run it up. And we'll put it right here, which ties them together.
Yep. Because you'll come in on the back side and loop them all and come back to here, right?
Yep, we'll loop them all on the bottom side.
Okay, so Jeremiah was saying in the beginning, and you've seen us dealing with these test switches through these webinars, so you know that my voltages are always the long swing with no place to put my duckbills in, and very true to what Jeremiah said, these phenolic barriers between them is always going to be on your voltages. Okay, so if you had all the whole phase grouped together where you had your voltage, you had your return and your shunt on your CT, so as you had all A phase, then there'd be a phenolic. So you could have 3 with a phenolic, then 3 with a phenolic. In this case, since the voltages are all one after another, it's going to be phenolic, phenolic, phenolic. But this divides those. My solid's always going to be my neutral. And then we know the long swing with a place for duckbills is always going to be the return for my shunt. So if you've seen us working with the ones on the test bench, you know they can get pretty awkward and complicated. The ones we have on the test bench for the webinars is about as awkward and complicated as you can get. And so you just need to look at them and remember the rules Jeremiah said on phenolics for the voltages, long swing with no place for a duckbill's got to be my voltages, long swing with a place for my duckbill's got to be my returns. And then, of course, short strokes are always my shunt blades.
So now we will start with our currents. Now we want to match A current to A phase. Because if we don't, we have problems, will not meter correctly, and then we're not going to make the money we should be making.
That's right.
So A current, red wire for A phase. Then we'll run it right down here. And we will run it to the one that don't open all the way. See, it don't open all the way, therefore it will not be, it's got that right yonder on it. So we know that right there is a potential or a current. Then we'll do B phase. We're going to have yellow because that was our B phase voltage wire color. We'll start up here at the top. In there.
Voltmeter from Ray. Right. Yeah, we need a voltmeter. So we can check it all out after we're done.
We'll run that to right here, our other one.
Yep.
Now, one thing I always like to recommend is have someone else, even after you wire it, come back and check. Double check it before it goes out into the field, or even if you're out in the field wiring it, have 2 sets of eyes on it.
That's right.
Because it is easy to make a mistake, and when you just, I mean, I done it earlier, out of habit, was going to put that neutral right there till I realized, oh, it's got a switch on it. Alright, so we'll do C phase, our blue wire. So I'm going to pull it out. I will strip it off. So I got to put a terminal on it. Man, you know that one mashed good. I couldn't even get it out of there.
So a lot of these were, we just left them terminate and everything, but we wanted to show the full process on C phase on both of them. So we were just showing actually stripping, crimping, and all the other stuff.
So you want to try to keep it as uniform, or I do. I think it helps out if you ever have to come out and troubleshoot in the middle of the night. Hope that you don't.
I can see where wire tying them would.
Yeah, if you wire tie them up, you could have them all brought up to where they'd be nice, and so if you opened it up, it would be pretty.
Yeah, and pretty's good, but I just want to be able to find everything, trace everything.
Yeah, I mean, you're out there and it pouring down the rain.
Yep.
You have to cut the wire ties off, I guess. I think these crimpers are raised, ain't they?
Yep.
You can tell they're adjusted well. So that is the top side done. You can see we got red, yellow, blue done. Our voltages are done. Our returns are done.
So what's your flow of current then over here from the way you got it wired?
So return potential would be A, return B, return C.
Right. So which way is your current going through these wires?
Oh, they're actually coming. So you're coming from your transformer this way up to your meter base, then it's going to return right here, and then we're going to loop down here at the bottom our returns together and tie them to the can
That's
for a
right.
drain.
So it'll come in through here in the bottom, and then it'll come through the shunt blade. Because remember, we're disconnect when we open that, we disconnect the current or shunt the current coming from the CT. So it comes from here, goes up in through the meter through here, and then returns back through here, back through the return blade. So that's my circuit. I'm going from here, the red, which is A phase, and I come back through here and I come back to the return. And my conductor's coming from the transformers coming in through the bottom.
Come in through the bottom and make up right here. One thing to think of is when you have the voltages open, these right here are still hot. It's just the top side of it when you open them that kills it.
Yes.
And turns it off.
And that is a good point, because there are times when we've talked about it before, when you're testing in substations and stuff, where they want you totally disconnected because they don't want even the possibility of a backfeed. So when you open up down here, if you want to make any connections, you connect here if you want to see anything. But remember, when we open up at a sub and we're driving everything, we come up here and we make our connections with our alligator clips here, and we drive the voltage, because then we drive from here on up to the meter. If you open those up and you connect it down here, nothing would happen. Okay, so when you're using like a 7 series, something has a load box with it has a voltage source as well, and you're trying to drive voltage to that meter, if you open these bad boys up, you better get on that top side or you're going to have issues. If you get down here, you're not going to get anything. It won't make it through here. So the flow is definitely up through here, and the flow here is absolutely through the shunt blade, through the meter, and then back down through the return back to here.
Yep. Okay, so we got the top side done. I'm going to close those for right now. Remember, this is not energized, so there's nothing coming through. I will put my jumpers on now.
And this is where Jeremiah is going to towel the returns together on the CTs. And that's why you can, when you get ready to do your measurements or a burden measurement or anything, as long as all of those returns are tied together on those CTs, you just need to connect onto one of them and you'll get the return back.
There's 3 of them, but I don't see the third one. See another one like that? You're trying to trick me.
I just happen to see it
Well, setting me up. I do want to, when we take this one off, let's show them. Something that's easy to do is the grooves and the hole on this right here. So you see, it's tight. It will not go on there. And them alligators will fit on the groove and it'll help hold it. And then the plungers that we have, that's what the hole's for, so we can actually hook in there. Some people will try to turn it, but it won't go. I mean, it'll go. I mean, you can force anything to go, you know that. And leave this smooth side up, and the alligator clips will not hold on to it good.
That's right. That's a good point.
So that's our solid neutral right there, coming down. We'll put it there. We're going. So now we're going to return. Now we don't return on the potential, which is the short one. We got to return on this one, which comes off the bottom, and is actually our return that we could put a duck bill into if we wanted to. That right there, we're in loop with the meter at that point, with our test equipment. So on this one, we'll have that one going there, and then we will put another one, which I found out in the past, it's best to put one terminal upside down, so to say, so it'll fit in there. Then you put your other one like that, and then you can put that on there.
So you're not stacking the crimps on top
Nope.
of one another, because if you stack the crimps up there, you start running out of room. Right?
Yep.
So you have to turn crimp outside, crimp outside. It's the little tricks.
The little tricks that you learn out in the field after
That's right.
making the mistake 3 or 4 times. So we got that one done, then we're going to come over here with this next return, which is the big one. So we'll put this one, which is turned upside down on that one. We'll turn it upside down here. And then my lovely assistant John already had that one ready.
Someone has to be Vanna White. I'll take her money.
You sure don't look like her.
No.
I'll say that.
I'll take her money.
See that one? Then our next one will go here for a return. So at this point, we also want to remember that we have to ground our can. So we'll put one there, and it'll actually go down in a minute, and I'll show you, to the can. And you take it and you can put it right there. Turn that over so the crimp's on top.
So he's just connected to his case ground right there, or his cabinet ground, or whatever you want to call it.
And it is grounded at that point in time. So then if we had our wires coming from our transformer, our CTs, they would actually come in through here, and we'd actually make everything up on the bottom. You'd want to use the same color. So A, red, same color for your voltages as you're going to your CTs. That right there would all match, and then you would know what A was. So if you was looking in the transformer, you would know that should go there and there. So if you wanted to ohm it out or anything like that, you could actually see it and see it work.
Yeah, you want to check it out?
So let's test our job, see if we done.
Bum, 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 ba, da, da.
This don't beep. This one don't beep.
Hold it.
So you want me to check from here to here first?
Mm-hmm.
Good?
Yep.
This should be A, I think. So we got connection there. We'll do B next. Connection there. Let's see here.
Yep.
Connection there. C face. No, so that would work. Now we should be able to go here. A. Got it.
Yep.
B.
Got it.
Got it. C. Got it. Yeah. Now let's just check our return. And it should actually read all the way through to there. You're doing it right.
Yep.
So,
Good deal.
So we're all
So check
wired
the
up on the
continuity
top,
on all
right.
the current pads and all the, which correspond to our wire paths. So looks like she's wired up all right. So hopefully some of the things you've noticed for the separation, and probably out in the field, you probably would put a little zip tie here. Probably maybe a zip tie over here.
I had lots of people in the chat group saying, please zip tie that.
Yeah, I know.
Yeah.
It's driving, and I'm going to tell you
can't
something
stand
about
it.
this. You can say what you want to about it, and I love it when people that don't know really what guys do talk about it. There is pride and workmanship out there, and I can tell you right now that guys, it'll bother them not to see that wire
That's
tied. So
nutty.
I knew somebody would say something. So now Jarrett saying the chat room got lit up with people saying, please put wire ties on there. Yeah, absolutely, you'd want to clean it up. Okay,
Yeah.
so absolutely.
Let's do something about it when somebody else comes and opens it up and
That's
it
right.
looks neat and they
That's
can tell
right.
that it was your work.
That's exactly right. You take pride in your
Yeah,
workmanship.
it bothers me to.
Cool.
So when this is off, I'll tear it out so nobody has to see it again.
Well, hopefully we covered a lot of stuff for you guys as far as wiring up one of these 9S sockets. You can see the flow, things that we've talked about before on previous webinars, when we've talked about test switches a lot and talked about the flow of things, so that now you can see the actual flow where we come in here from the bottom, and you can see that the flow is up here, so you'll come in through these CTs here, right, and then you'll go up through the meter, then you'll come back on the return over here on A phase and come right back in here. So you come right back in here, and then you can see the flow where we'll come in here from the bottom, with our potentials right here, and then they go from here up into the side of my meter right here, and then my neutrals around over here on this side. So my voltages are here and here, and then my currents are here and here. Here's the flow right here for my currents. So, and then as long as I've got these returns all tied together here, then my returns coming back from the CTs are all tied together, so I have a common return. And some people don't do that. They run separate returns for each one of their CTs, and we've talked about it in the webinars, and that means a little bit different on how you're going to do the testing. Like on a burden measurement test, for instance, you'd have to move it to pick up, because you're trying to measure out to the CT and back on each particular phase when you're trying to do a burden measurement on A and B and C. So you would have to move your neutral connection every time you tried to measure the burden on A or B or C. But if they're tied together, I just leave them and I just make one connection and I don't have to move it. Okay? Good job, brother. So, so it looks like everybody out there now can wire up a 9S can. Hopefully everybody in the offices are probably trying to go out and grab some cans this afternoon and start wiring some stuff up. But hopefully you've got the idea. And, you know, and this all gets back to what we've said over and over and over and over. These and this, right? So just think about the flow. Just how, you know, Jeremiah kind of looked at things at the beginning, opened stuff up and made sure he knew where the flows were going. And if you understand what's behind the wires, if you understand the actual flow, what each thing does, what my returns, my shunts, and how they should flow through there, it helps you a lot when you get ready to wire one of the things up. So don't just get in the habit of pushing buttons. You know, ask the questions, call and ask us, ask guys that have more experience there at your utility, but know why what's going on, okay? Know why when I hit the button it does that, okay? Don't just tell me, well, I hit the button, man, the needle didn't move. I had that happen to me many, many years ago when I first got started. A guy told me, well, the needle didn't move. And I asked him, what does that mean? I don't know, the needle didn't move. I said, okay, no, know what's going on and why the needle did move, okay? That's what's going to keep you safe. That's going to let you do your job better, and you're going to be more valuable to that utility company, okay? So we appreciate everything today. You guys be safe out there. Please give us ideas on the upcoming webinars we've got coming up, okay? We've got one we're working on the advanced one. If you've got an idea you'd like to see, something that you've heard maybe that one of our products can do, but you've never seen it, you know, and you want to see it, we're thinking about doing that advanced meter tech testing, whatever you want to call it, but just an advanced class where we're going to show you some things that the equipment you wouldn't use every day, but then you might say, well, if we had used that at that site, and the suggestion got this started was a particular site and a particular problem they had on it, well, when they used the equipment in a little bit different way to try and troubleshoot it, and it got me thinking, well, maybe we should show this more advanced class of maybe some things that people don't normally use the equipment for. So if you have ideas for that, please send that in to us, all right? And all the promos and everything are still running. Nothing's canceled so far, so all that's still running. Once again, remember, if you get ready to place an order, and we didn't, it was a previous quote, we will give you the promo. So remind us of it and say, hey, I'm about to order the 3 Series. Don't I get the 3 Flexes free? And but we've got that in our heads, but just in case, you might ask about it, all right, if it's not on there. Thank you all. Appreciate everything. Looking forward to wiring up a 2S on Thursday with Jeremiah again. So if you got any suggestions on that, holler at us. But more importantly, be safe, get home safe. If you got any ideas, sling them at us, all right? Thanks. Appreciate y'all.